Solving equations with variables on both sides. Now what does that look like? Well, we have here an example of an equation with variables on both sides. 5x minus 10 equals 3x plus 12. So we have a variable on the left and the same variable on the right. Now since they both are the same variable, in the end they will have the same numerical value. All right, so let's see. How do we solve one of these? Well, the only real difference in solving these and solving two-step is the first step, which some call all my x's live in Texas step. This step moves the variable to one side, okay, usually the left, but actually you'll see as I go through some examples, it doesn't matter if you move all the variables to the left or all the variables to the right. Okay, and you do this by doing the opposite, just like you did when we had two-step equations. So, if we have this example, let me draw my line here. Okay, 5x minus 10 equals 3x plus 12. So I want to get the x's, so I'm going to move the 3x. The whole term is going to move to the other side. Well, to cancel out that whole term, I'm going to subtract 3x. I'm not trying to get rid of the 3 that's with the x, so that's why I'm not dividing. I want to move the whole term, which is a positive 3x, so that's going to become minus 3x. So what I do to one side, I have to then line up the minus 3x with its x term buddy there. Okay, so when I do this, I end up with 5x minus 3x. That would give me 2x. Bring down the minus 10 equals, and now there's still 12 on the right side. All right, now that looks like a normal two-step equation. So we have here 2x minus 10 equals 12. So if that looks like our two-step equation, we do like we've been doing, which is cancel out the term not directly with the variable. So let's cancel out that minus 10 here. Okay, now we're left with 2x equals 22. And the last step, now we're going to cancel out that 2 and get rid of it from the x. We're going to just divide by the 2. So x will equal 11. And that is all. Okay, so let's continue on and see the next problem. Here's another example. Even when the terms seem mixed up, the procedure stays the same. So mixed up meaning, like on the left side, many times they put the variable term and then the numerical term, but this time it's the other way around, but it still is going to be worked out the same way. I notice I have a variable on each side of the equation, so I'm going to move my variable terms to the left side. Now subtract the whole term. I'm canceling off that whole term. Line it up over here, so minus 25m. Okay, starting on the far left, I have the negative 2, so I'm going to bring that down so I don't forget about it. Now right here, that says negative 5m minus 25m. That's going to give me negative 30m's equals 88, and that's all that's on that side. Now I have my two-step equation. Looking at the side that has the variable, I need to cancel out that term not directly with the variable, so opposite would be to add 2 to both sides of the equation, bring down what is still on the left side, which is the negative 30m, add here, okay, last step. Divide both sides by negative 30 to cancel out that negative 30 that's getting multiplied with the m, and it will leave you with m equals negative 3. Okay, so now as I've done those two problems, I've moved all of my variable terms to the left side. But let's find out if it really matters. Same problem we just did. Okay, so I'm going to take this time, I'm going to move the negative 5m to the right side. Well, it's a negative 5m here, so to cancel the whole term off of the left side, you need to add 5m. Okay, on the left, I still have a negative 2 equals 88. Now, 25 plus 5 will give me a positive 30m. Next, I need to get rid of that term not directly with the variable, which is that 88. So subtract 88 on both sides of the equation. It will give me negative 90 on the left side. Bring down the 30m. I'm going to divide both sides by 30. And negative 3 equals m. So let's see, was that the same answer we had before? M equaled negative 3, negative 3 equals m. So it doesn't matter if you want to move the variables to the left side or the variables to the right side, but more commonly, they usually move the variables to the left side, but it's up to you. Okay, I'm going to try some additional examples. So on this one, I have 4x minus 19 equals x plus 11. Well, on this one, I'm going to move my variable to the left side. So this is a x. Hopefully we know if there's no number in front of the variable, there's an invisible 1. So this is positive 1x. To cancel it out, I'm going to subtract 1x from both sides. That will leave me with 3x on the left side when I calculate. Bring down the minus 19 equals 11. Now from here, I'm going to cancel out the term, not directly with the variable. So that's going to be the negative 19. So we add 19 and add 19. Cancel those out. We're left with 3x on the left and 30 on the right. Finish it off by canceling out that 3 by dividing. X is equal to 10. So there's your value for x. So on that one, I put that example there because you need to remember there's an invisible 1 when the variable is just by itself. Next example. So let's take a look. 3x minus 53 equals 5x plus 13. So on this one, I am going to move my variables to the right side. Okay, so if that's a positive 3x, I'm going to subtract 3x on the left, subtract 3x on the right. That will cancel those off. I will now be left with a negative 53 on the left, and 5x minus 3x would be 2x, bring down the plus 13. Okay, so now I need to look at the side that has the variable and cancel out the term not directly with the variable. So that's going to be that positive 13, that plus 13, subtract 13, subtract 13. When I do that, I end up with negative 66 equals 2x is still on the right. I'll divide by 2 to cancel that 2 that's getting multiplied with the x. Divide by 2, and that would give me an answer of negative 33 equals x. Or I can say x equals negative 33. Same thing. Okay? All right. So on those two, I did each part separately. And I am going to, and what I meant is I moved my variable terms in one step, and then I moved my numerical terms in another step. This time I'm going to move them both at the same time. So let's see how that looks. Okay, so I'm going to take the x term, I'm going to move that to the left side, and I'm going to take the numerical term and move that to the right side. Okay, so My negative 5x is going to cancel off of the right by doing the opposite of adding 5x. Now I need to add 5x underneath the other x term on the left side. Now my 19 is going to move to the right side, so to move it over there, I got to cancel it from the left by doing the opposite of subtracting 19. Subtract 19. Okay, so now what do I end up with? On the left side, I have 55x plus 5x, that's going to be 60x. And on the right side, negative 41 minus 19 is negative 60. Okay, so from here, I still need to divide by 60, and x will equal negative 1. Okay, so I just did 2 steps in one shot. I just like to share that with you in case you're an individual that this works for you and you prefer to do this, moving them both at the same time. All right, so the last thing you will have is your example. So which of the following is a solution to the equation 7x plus 59 equals negative 2x minus 32? So you decide, how do you want to solve this one? Do you want to move all your variables to the left side? Do you want to move them to the right side? Do you want to do one step at a time, or do you want to double up your steps? Whichever you choose, just give it a try. Hopefully your answer is there. If not, please let me know and I will help you out. Good luck.